Hello everyone, welcome to Geeky Nerd. Today we will begin with the part 2 video of boats and streams. Before moving into the video, I hope everyone would have become thorough with the basics of boats and streams. If you have not seen the part 1 video, click on the card or the link in the bio. In this video, we will be discussing the relationship between speed of stream and speed of still water. Like, share and subscribe the channel for more interesting concepts and shortcut methods for solving them. Without wasting any time, let's head into the video. Let us get into the first concept. If the speed of the stream is a kilometer per hour and a boat or swimmer takes n times long to row upwards as to row down the river, then so in the concept it has been given that speed of the stream as a kilometer per hour. The boat or a swimmer takes n times long. For example, if I take 1 hour to row downstream, I am taking 4 hours to row upstream. In such cases, a boat or swimmer takes n times long to row upwards as to row down the river. In such cases, if we want to determine speed of the boat in still water, we can use the formula of A of n plus 1 the whole divided by n minus 1, where n denotes the number of times taken by boat or swimmer to row upwards as to row down the river. A refers to the speed of the stream. It can also be determined using the traditional method. Here we are discussing about the time taken. Therefore, we can equate the time taken to row downstream with the time taken to row upstream and determine the speed of the boat in still water. We know the basic formula of time taken as distance traveled divided by speed. Therefore, time taken to row downstream is equal to time taken to row upstream. Therefore, distance divided by speed of downstream is equal to distance divided by n into speed of upstream. Here, we are multiplying n with speed because a boat or swimmer takes n times long to row upwards as to row down the river. We know that the speed of the boat in still water as x kilometer per hour. Therefore, substituting it in the above equation, we get speed of downstream becomes x plus a and speed of upstream becomes x minus a. Therefore, equating both the times, we get d by x plus a is equal to d by n times of x minus a. On substituting the known values in the final equation, we can determine speed of the boat in still water. Let us solve some examples to understand this concept. Rajneesh can row 12 km per hour in still water. It takes him twice as long as to row up as to row down the river. Find the rate of the stream. From the question, we can understand that still water speed x is equal to 12 km per hour. It takes Rajneesh twice as long as to row up as to row down the river. Therefore, n becomes 2. We need to find speed of stream. So, from the concept what we learned, we know that still water speed is equal to speed of stream multiplied by n plus 1 the whole divided by n minus 1. Here still water speed refers to the speed of the boat in still water. Therefore, substituting the known values, we get 12 is equal to, we don't know speed of the stream, we assume it as y. We know the value of n2 plus 1 divided by 2 minus 1, which implies 12 is equal to thrice of y, which implies y is equal to 4 km per hour. Therefore, speed of the stream is found as 4 km per hour. Let us move on to the next question. Ashutosh can row 24 km per hour in still water. It takes him twice as long as to row up as to row down the river. Find the rate of the stream. So in this question also, speed of the boat in still water is given That is x is equal to 24 kilometer per hour. It takes him twice as long as to row up, therefore n is equal to 2. We are asked to find speed of stream. So let us try to solve this question by traditional method. So we will be equating downstream time, that is Td, and upstream time, that is Tu. So we know that time taken is equal to distance by speed. Therefore Td becomes downstream distance divided by downstream speed, and Tu becomes upstream distance divided by upstream speed. So here distance remains constant for both. Therefore d by x plus y becomes equal to d by x minus y. From the question we know that it takes him twice as long as to row upwards. Therefore the same equation becomes 1 by x plus y is equal to 1 divided by twice of x minus y. Upon substituting the known values we get 1 by 24 minus y is equal to 1 by twice of 1 by 24 plus y becomes equal to 1 by twice of 24 minus y. On solving it, we get 48 minus 2y is equal to 24 plus y. That is, 3y becomes equal to 24. Henceforth, y is equal to 8 km per hour. So, we have found out from both the questions the speed of the stream. In case if speed of the stream is given and speed of the boat in still water was asked to be found, we can use the same formula and interchange the known quantities. A man rows a certain distance downstream in x hours and returns the same distance in y hours. When the stream flows at the rate of a kilometer per hour, then the speed of the man in still water. So it has been given that the time taken to row upstream and time taken to row downstream. Let x be the time taken to row downstream and y be the time taken to row upstream. It is given that let a be the speed of the current. In such cases, speed of the man in still water can be determined using the formula speed of the man in still water is equal to a of x plus y divided by y minus x. In case in the question, if speed of the man in still water is given and if the speed of the man in stream or speed of the stream has to be found out, then speed of the stream A is equal to b of y minus x divided by x plus y. Here A is the speed of the stream and B is the speed of the man in still water. So this concept too has a traditional method which makes it easier for understanding. So we can clearly say that in the question, the distance traveled downstream and distance traveled upstream remains the same. Therefore, we are going to equate the distance traveled downstream and distance traveled upstream. We know the basic formula of distance as time into speed. Therefore, distance downstream is equal to downstream speed multiplied by downstream time, which in turn will be equal to upstream speed multiplied by upstream time. So upon substituting the known values, we derive at the final formula of x of b plus a is equal to y of b minus a. Of the four unknowns given in the formula, x, a, b and y, three of them would be given and the remaining one will be asked to be found out, and we can use this formula to understand it pretty easily. Let us solve some examples. A boat covers a certain distance downstream in 1 hour while it comes back in 1.5 hours. If the speed of the stream be 3 km per hour, then what is the speed of the boat in still water? So we can understand from the question that Td is equal to 1 hour TU is equal to 1.5 hours. Speed of the boat in stream A is equal to 3 km per hour. That is speed of stream. We need to identify speed of the boat in still water. That is B. So, in such situations, when the downstream time and the upstream time are given individually and the speed of the stream is also given, then speed of the boat can be determined using the formula speed of the boat in still water B is equal to A of y plus x divided by y minus x. We know the values of A, TD and TU. Here, TD represents x and TU represents y. Therefore, on substituting we get thrice of 1.5 minus 1 divided by 1.5 plus 1 divided by 1.5 minus 1, which in turn will give thrice of 2.5 divided by 0.5, which is equal to 15 kilometer per hour. Therefore, when individual downstream time and upstream time are given and any one of speed of the stream or speed of the boat in still water is given, we can utilize this formula and find out the unknown value. Let us solve one more example. A boat covers a certain distance downstream in 4 hours but takes 6 hours to return upstream to the starting point. If the speed of the stream be 3 km per hour, find the speed of the boat in still water. So from the question, we can identify that downstream time, that is x is equal to 4 hours. Upstream time y is equal to 6 hours. We know that the speed of the stream is equal to 3 km per hour and we need to determine speed of the boat in still water. Let us solve this question through the traditional method. So from the question we can clearly see that distance downstream is equal to distance of upstream. We know the basic formula of distance as speed into time. Therefore, we can rephrase the equation as downstream speed multiplied by downstream time is equal to upstream speed upstream speed multiplied by upstream time. We know the necessary values. Upon substituting, we get downstream speed will be x plus 3 multiplied by downstream time, that is 4 hours, will be equal to upstream speed, that is x minus 3 multiplied by 6 hours. Upon cancelling we get this as 3 and this as 2. Therefore, we know that x plus 3 divided by x minus 3 is equal to 3 by 2. Upon solving we get 2x plus 6 is equal to 3x minus 9. X is equal to 15 km per hour. Thus, we can calculate either speed of the stream or speed of the boat in still water if the individual time taken for downstream and upstream are given along with any one of the speed. Through this video, we learned the relationship between speed of still water as well as speed of stream. Problems were solved via shortcuts as well as traditional methods. Viewers can choose any method depending upon their convenience. I insist all the listeners to practice solving more and more problems so that they can increase their confidence. Like, share, and subscribe the channel and convey it to your friends so that they can be benefited. Until we meet in the next video, thank you.